Good day to all. This will be our second part involving discussions in business networks and telecommunications. And make sure also to watch our first part so that you can connect to our discussions or relate to the explanations here in the second part. Welcome once again. And now let's begin. Let's start with protocols, which is a set of rules governing communication between computers. Now, some protocols are designed for wide area networks, local area networks, and wireless communications. Well, for protocol being set of rules, this would serve as the handshake, which signifies the agreement of one computer over the other in terms of the connection. And then the most important set of protocols that I'm pretty sure, if not everyone is familiar about this, but I'm pretty sure you have met this somewhere or sometime, is called TCP or IP, which is Transmission Control Protocol and Internet Protocol. Here we can see that it is a set of related protocols wherein the first one, or part TCP, ensures packets arrive accurately and in proper order, while IP would ensure efficient delivery of packets from node to node, for example, from one computer to another. The TCP/IP would, in other words, overall ensure that packets are accurate, orderly, and are delivered efficiently from point of origin to destination. Here are some terms that we should familiar ourselves with: internet backbone, the highest speed channels. Host is a computer connected directly to that channel called internet backbone, while the IP or internet protocol number is a unique numerical identification for a network device that is, of course, associated with that network. Another one would be the DNS, or a domain name service that associates a character base name with an IP address. The IP address can be static, which means permanent or fixed, while dynamic is temporary or changing. And the IP number for dynamic is nice on the sense that it provides flexibility when the number of IP or internet protocol addresses is limited. Okay, then Ethernet, which is something, a term that I would say very interesting and nice in networks to speak of, especially that it's ether, so something like valuable. LAN protocol, this is local area network, and of course, it's a set of rules using cables. Could be coaxial or Cat5 or 6 twisted pair cable. Now, if we attach the word gigabit to Ethernet, that would result faster Ethernet connection of 1 gigabytes per second or greater. Then we should also take note that devices on network contend with other devices for transmission time. Well, that's true also. So as more devices are connected to the network, then there would be some competition in some sort of way or ways. Another one, another acronym that we should familiarize ourselves with would be the CSMA/CD. CSMA stands for Carrier Sense Multiple Access, and then the CD is with collision detection, which is a protocol that ensures that there are no collisions in transmission. This is very good so that when information flows, we would be avoiding the unnecessary delays of the transmission, because there could be some information that would collide with each other or bump with each other. It's like the literal pipe. We can actually view a network as a pipeline for our water, for example, wherein if there are a lot of devices, so the flow of the water will be divided or subdivided to such. And if, let's say, there would be a lot of water, let's say this is now a bigger pipe, then the water sources would collide with each other. Next would be wireless protocols. One is IEEE, which is 802.11. This is the normal sort of code that we can see on our connections. This is a family of wireless protocols known as Wi-Fi, or here you go. There is now your meaning. What do you mean by Wi-Fi? Wireless fidelity. So that could be a sort of trivia. It supports wireless communication within 100 meters of router, and 802.11 subtypes support various distances and speeds up to 248 Mbps, megabytes per second. Hotspot is also nice, wherein this is an area that normally people can easily gain access to a network, or the network is basically strong or stronger or the strongest on that area as compared with the others. And then this is a connection between wireless device and a wired network. So example, we have our phones, wherein we can use that to access network. Although the access could be limited within the range or area of equipment. So I said hotspot is normally that area that will have the connection the strongest, if not stronger or strong. Then next would be encryption, which is a very good method or way by which we are going to translate readable messages to unreadable ones from the source text to a cipher text. And to be able to decode the cipher text, we need a decoder or decryption key. Uses encryption keys shared only between sender and receiver. So the receiver should have the key to be able to unlock or decrypt the encrypted messages. Another one would be Bluetooth. This would allow devices to communicate within 10 meters, and this can also enable exchange of information. This transmits voice and data. That's very true and considered a PAN technology. What is PAN? That's personal area network that we have discussed on our part one. Make sure again to check that one. This is a wireless home network, figure 6.4, wherein we can see the wireless router here and the cable modem so that we can have our internet connection. And this can be shared, of course, within the house, or could be some certain area, so meters from the source, so that others can gain access. But when there's password, they should know the password, of course. That's part of our security access. Now, we have also other terms like the WiMAX, which stands for Worldwide Interoperability for Microwave Access, that increases range and speed of wireless communication. I'm not sure though if this is applied here in Philippines, but considering the timeline, like the time frame of this edition with today, 2021, perhaps there is. Works with MANs, the Metropolitan Area Networks, and would enable internet connection while even in a moving vehicle. Another one is MBWA, the Mobile Broadband Wireless Access, that is similar to cell phone communications, compatible with Internet Protocol services, even the Wi-Fi and the Bluetooth. Would also support Wi-Fi routers on cell towers to allow use of VoIP by cell phones. Now, we might be wondering what we mean by VoIP. It actually means voice over internet protocol. That's VoIP, which basically means that a call is made through internet connection instead of the landline or by telephone that is usual that we do. So we use the internet to call. This is okay. However, the issues would be bad quality of the audio or call, because when we use the internet, of course, we are talking about packets, and the packets are to be transmitted by that TCP/IP. And you know that if the protocol does not work that well because of the internet, so packets are not efficiently delivered and not accurate and relevant as intended. So that's the issue. And this is how WiMAX works. Again, wireless connection, and this is worldwide interoperability for microwave access. So this is the home, business, or public hotspot wherein we can really connect through certain networks or by certain networks. Then we have the WiMAX and the WiMAX base station, another station, and we have there the internet. So this is how it works. Then our wireless protocols could be in these forms, but I would say this is the common or most common, if not just common, protocol among the items here. 802.11a, max range is 75 meters, 250 feet. Maximum speed is 54 Mbps, and main use is for the local area network. So just for within, for example, a house or close area only. But if we talk about the PAN or personal, as mentioned a while ago, we have the Bluetooth concept and protocol. But for the metropolitan, we have the WiMAX. And if we talk about global, this is nice, the MBWA, which is for mobile voice, data, and internet communications, which is mobile broadband wireless access used in, again, cell phones. Now, there are generations in mobile communications. I can just imagine like a lot of our communication channels are now at 4Gs. Networking professionals refer to generations of mobile communication technologies. In the first generation, we are using the analog or close to the machine or machine-like. Second generation or 2G use digital voice encoding, while third generation or 3G increase speeds that support video, video conferencing, and internet access. So this is where we actually started for the time in the 2010s. I can recall that in my experience though. I don't know with the others. But 4G, fourth generation, is digital only with packet switching and tighter security. And this is what we have now most often with our gadgets and our SIM even for the cell phones and the networks. The variety of options to choose from when subscribing to internet networking or network services. Downstream is the speed of receiving from network. So the network to us, that's downstream. Upstream is speed of transmitting to the network, from us to the network. Services with lower rates for upstream than downstream are suitable for most individuals and businesses. What could be the reason for that? Allow me to give you a time, like 30 seconds. You should be pausing this video and think about it. And you should be able to think about this now. Probably the reason for this one is for the most of individuals and businesses, we are more into receiving certain information from the network. So that's why downstream would be very important to us than our upstream choices for the services. Then next to that would be the typical features of internet services from dial up down to OC-48. This is not to be memorized, but at least depending on our needs, we can look into what is the best for us and our capacity and our gadgets or hardware in the company with the following monthly fees accordingly. Cable also is important. These internet links provided by television cable firms. And literally there is a cable, like wires connected to internet server. At residence, cable is split into TV set and computer via a bridge called a cable modem. A modem stands for modulator demodulator. Cable shared by all subscribers connected to the node could be a certain computer that acts as our server. Communication speeds may slow during peak time and as more subscribers join the service. As there are many users connecting to a network, then the connection slows. Again, similar to the concept of pipes on the waters and with connection to our water source. Then DSL is a digital subscriber line wherein data remains digital through entire transmission. And this uses telephone lines. Usually this is our case, especially if we have telephones that are required to have the internet connection. And the telephone lines will be connected to the DSL bridge, which is also the modem. Several types would be asymmetric and symmetric. Asymmetric allows different upstream and downstream rates. Symmetric provides high speed in both directions for short distance communications. Transmission bit rates closely related to distance from telephone company's central office. So this is the good thing here about the rates for transmission. So this is closely related to distance, meaning to say if there is greater distance, then the rates should be higher. And if there would be shorter distances, then expect lower transmission bit rates. Now we have the T1 and 3T or T3 lines rather, which are point-to-point dedicated digital circuits provided by telephone companies. A T1 line is made up of 24 channels of 64 kilobytes per second, while the T3 has 672 channels and 64 kbps respectively. So in terms of channels, T3 is better, but they're expensive, used by universities and large companies for backbone, which is our source and internet connections. Satellite would be perhaps one of the nicest things that can be considered for our connection. However, for sure, this is going to be expensive. Not everybody can afford. Service provider installs dish antenna that is tuned to a communications satellite and speeds up to 45 megabytes per second, used for private homes and for mobile uses such as shipping and tracking. So if you can see that disc-shaped ball that is placed normally on areas close to the roof, higher elevated levels. So that's the satellite and would enhance, of course, the speed of our internet connection. Then GPS, the Global Positioning System, is a free satellite service that provides location information. We know that also. We can make use of our Google Maps, for example, powered by GPSs. But normally that is with internet, but if without internet, well, we can have GPS also. Then fixed wireless is a point-to-point transmission between two stationary devices, typically between buildings. The keywords are fixed, so the devices are not moving or not being moved. And then we talk about connection that is not connected by any physical devices or cables or whatsoever. So this is, again, without wires. WISP, Wireless Internet Service Provider, specialized in fixed wireless service, because the normal thing is that when we are going to ask for an ISP to place or put certain gadgets on our homes, they would place that accordingly on a certain area. And it's not like it's moved by next day or next week or next month or next period. So it's going to be fixed there. And then if fixed wireless, so that devices are stationary, in other words. Highly modular and scalable, it would be easier, of course, to upgrade, in other words, suitable for both rural and urban areas, so province and city areas. Fiber to the premises can also be nice. And this connects a building to the internet via optical fibers. And we have the fiber to the home or FTTH when the optical fiber reaches the subscriber's living or workspace. Subscribers, though, connect computers or local area network routers to an optical fiber socket. Optical carrier or OC provides services through optical fiber lines. It is expensive and very high connection speeds. Provides speeds in multiples of 51.84 megabytes per second, the base rate bandwidth. It is typically used by ISPs or internet service providers, then providers of search engines, in other words, the Google, then for Internet Explorer team, the Mozilla Firefox team, and the like, or likes. Content rich or high traffic websites. So there would be using optical fiber lines now. Again, they have the money, the resources. Take note that is expensive. And with that cost, though, the connection speeds are very high. So they will invest and they can really invest into such. Next is BPL or broadband over power lines. This uses electrical power lines to carry digital signals used by utility companies to monitor power consumption down to household, detect power failure in real time, track power outages by region, automate some customer services, and remotely control substations. So basically, there is real time detection of problems. There would be easier monitoring because data and information would be readily available by using of BPL. Speeds are similar to those of digital subscriber lines like telephones being required for the installation or the installation of the internet in the homes or on the homes that can be utilized for the connection of the devices. Then the future of networking technologies would have these trends and would have significant impact on businesses and management of information like broadband telephony. So we can make use of our internet connection to call. Then RFID, again, the chips that can be placed on certain products and we can easily monitor them because each item has a unique, for example, code, just like the barcode, but now it's a chip. Then convergence of digital technologies wherein these technologies are grouped so that they can produce the desired results. The broadband telephony, as said a while ago, would use VoIP. I explained that. This would have flat monthly charge instead of per call charge, since the internet normally connection is done flat charge. However, if there are like additional data consumed with other items, especially if not unlimited access of internet, which is also open access, there could be additional charges, but that would be the exception. Different quality of sound from traditional telephone services may not allow direct calls to emergency numbers such as 911. Yeah, because we are using now the internet to call. And when internet link or power is down, then no phone service. So no internet, no Wi-Fi connection, synonymous to no phone calls. RFID, we have explained that already. These are tags which are tiny and need little power. Then objects are embedded with tags that contain a transponder, a radio transceiver, which is combination of transmitter and the receiver activated by a signal transmitted to it. Then tags are encoded with EPC or electronic product code. It's like the barcode. Then readers, or example, the scanners, decode data stored in tags memory and pass the data to a host computer. What is good here is that our databases will be updated, especially, for example, for the simple one. Let's just begin with barcodes, wherein once that particular barcode is scanned by the barcode scanner, then our systems will be updated, like our sales, our cost of sales, our cash balance, our inventories, and so on. This is efficient for large companies, but for smaller companies, however, it would be expensive. I'm talking about RFID. Then we have the applications or RFID. So example would be for access control. Example would be cards used to replace door keys. So instead of the keys, we use cards. People tracking with the RFID, we can easily check where our kids are if they're moving from one area to another area, especially to those areas that we don't want them to go. So this is a tracking device also, even for kids. When we are, for example, in our another room, we can track them if they are moving. So we can check that, oh, they are moving from certain areas, so we have to go to their rooms. It's really great for other countries. Then track prisoners also on probation and prevent fleeing. Yeah, this is a great example, like prisoners which are or who are basically tracked by management of prison. Then animal tracking can track pets. I like that. Livestock management, we can track life cycle of farm animals. For example, for feeding and immunization, we can also track them based on groups and equip each cow with a unique ID to track diseases also. Those who have diseases will have different RFID codes. Then anti-theft measures, transponders integrated into car keys. Only a legal key can start the engine with the RFID. Transportation at airports, safety inspection of tagged luggage. Retail also, well, that's our example, like the Walmart with the RFID for the products. Tracking products in pallets and on shelves, contactless payment. Example also, if somebody would be getting certain, let's say, shirts and products of certain stores with the RFID, have you noticed like there are certain tags? If one would go out from the store, then certain scanners would make sound. So that's also the implication and the good impact for businesses, especially for having RFID in retail. For pharmaceuticals, reduce drug counterfeiting. Yes, that's true, because we have to monitor the actual medicine and the number of units and movement. So we can also check, for example, if our medicines are properly given based on certain, let's say, diagnosis from the doctors and medical recommendations. Healthcare, tag people who enter and leave an epidemic zone, especially nowadays. It's a good thing. Like if this is really the application of that, this is nice. Only if the economy can afford, though, like the pandemic times for COVID-19, we're in, people, for example, who have vaccine can have like their particular cards with RFIDs, or let's say some sort of gadget. So that's a good application. Then this can also be used in other areas like shopping. For future uses though, this list for figure 6.8 is the current, while 6.9 would be the future uses. So shopping activity, identify dresses in your size if you hold or wear a personal tag, and many more. So very interesting. For product information, scan an RFID tag of an item and download additional information from internet site to your cell phone. This is a good thing. Then manufacturer serving customers would send recall message to customer cell phone or email address. We can now easily communicate and contact with our customers. Appliances, example, washing machine automatically sets proper wash cycle based on information on tags attached to clothes. Now that is also a good thing. And agriculture, we can attach tags to crops that can transmit information about weather and soil conditions and trigger automatic irrigation. This is nice. Hopefully this would really happen in the future. And we don't know if it already happened. Then waste management, track hazardous materials to ensure proper disposal and sort recyclable items. For converging technologies, again, combinations of technologies used, like cell phones can act as web phones using VoIP. Television sets nowadays can also connect to internet, cable, and satellites concurrently. Our PDAs function as television sets and phones. Then portable music or video players will communicate with PCs to download files and transmit to wireless earphones. So it's like we can now easily transfer certain music or file from one source to another, or one gadget to another. Cell phones will read RFID on products to compare prices and then make purchases. So we can just scan, for example, certain RFID tags, and we can check the prices of them, and we can just use the app, for example, to purchase. So those things are going to happen and is happening perhaps in other countries and economies. To summarize, telecommunications is communication over the distance. Tele, which comes from the word telos, which means distance. Technology has changed the business environment, and in having the different media, we have also the different bandwidths. Networks are classified based on the reach and complexity. Some could be local, metropolitan, or wide. We can convert or turn a public network into a VPN, in which those who will access that public network will be required certain authentication measures and information like username and password. Then there are two ways to switch a communication line. It's either packet or circuit. The protocols of the network are sets of rules to which all devices on the network must adhere. And the common one is TCP or IP protocol. Again, stands for Transmission Control and Internet Protocol. Wireless technologies make it easy and affordable to create wireless local area networks and hotspots. Easier also to share our internet or Wi-Fi, and of course with proper authorization. Organizations and individuals have a variety of choices when subscribing to networking services. As internet links become faster, so using internet as ways and means of calling or acting as telephones is gaining in popularity. RFID technologies are very important for certain reasons and business applications that we have mentioned. Then, much like hardware, telecommunications technologies are also combining and merging. Increasing numbers of employees now telecommute. So that means that we are communicating in large distances. And with that, so that's the end of the second part. Thank you very much for listening, and God bless us all. Hopefully, you learned something from this particular session. God bless us all.